Assalamualaikum, salam sejahtera and good day to everyone. This is Yusuf Hamdani again. This is part 2 of chapter 9. This time we are going to look at how to conduct hypothesis test for the population mean. When it comes to hypothesis test for the population mean, there are two choices. We have to decide whether to use z-test or t-test. We use z-test when the population standard deviation is known, and t-test for the population standard deviation is unknown. For the z-test, this is the formula that you have to use to find the z statistic or z calculated value, x bar minus mu divided by standard deviation of the population divided by square root of n. There are three approaches to hypothesis testing. The first approach is to use critical value. Second approach to use p-value, and the third approach to use confidence interval. So let's take a look steps in critical value approach to hypothesis testing. There are several steps we have to follow. The first step, we have to state the null hypothesis H sub 0 and the alternative hypothesis F sub 1. Second step, choose the level of significance, that is alpha, and the sample size n. Step number 3 is to determine the appropriate test statistics. Then we have actually 4 types of test statistics to choose from. The first is z-test, t-test, f-test, or chi-square test. Number 4, to determine the critical value that divide the rejection and the non-rejection region. Step number 5, collect some sample data, organize the result, and compute the value of the test statistic. Step number 6 is to make a statistical decision and also to make a managerial conclusion, whether to reject or to accept the null hypothesis. So those are the 6 steps in the critical value approach to hypothesis testing. So here we have a hypothesis testing example. This is the situation. Test the claim that the true mean diameter of a manufactured bulb is 30 mm. Assume its standard deviation of the population is equal to 0.8. So meaning here we assume the population standard deviation is known. By referring to the 6th step in hypothesis testing, so we have to state in step number 1, we have to state the appropriate null and alternate hypothesis. So we write null hypothesis as mu equal to 30 because from the hypothesis statement there is a claim that the true mean diameter of a manufactured bulb is 30 mm. So we write our hypothesis null as mu equal to 30 and alternative hypothesis as mu not equal to 30. And this is a two-tails test because we use a symbol not equal to for our alternate hypothesis. So we always look at the symbols that we use for the alternate hypothesis to decide whether it is a two-tailed test or one-tailed test. So since this is a not equal sign, that indicates this is a two-tailed test. However, if we use greater than or less than symbol, that indicates it is a one tail test. So greater than or less than indicate one tail test, while not equal to indicate two tail test. So here we draw our distribution, normal distribution, where in this distribution we have a two area, rejection area, to the left and to the right. Step number 2 is to specify the desired level of significance for and the sample size. Suppose alpha is equal to 0.05 and n equal to 100 are chosen for this test. So since we use alpha 0.05, then we have to divide the alpha 0.05 divided by 2. Then we have an area equal to 0.025 to the left and 0.025 to the right, Sn to represent the rejection area. Step number 3, determine the appropriate technique. Since this is a situation where standard deviation of the population is assumed none, so we have to use the Z test. And then step number 4 is to determine the critical values. Since alpha is equal to 0.05 and it is a two-tail test, we divide alpha into 2, we have 0.025, and then based on 0.025 value, we find the Z value from the table, and the Z value is equal to 1.96 plus or minus 1.96. And then step number 5, we collect data and compute the test statistics. And suppose the sample results are x bar equal to, the mean sample equal to 29.84, sample size equal to 100. So the test statistics will be x bar minus mu divided by standard deviation of the population divided by square root of n. So x bar is 29.84, comes from the data that we collected, and then minus the mean of the population, the mu, which is 30, divided by 0.8, which is the standard deviation of the population, divided by square root of n, that is 100. So we solve this equation, then we get negative 2.0 as our Z stat value. Step number 6 is the test statistic in the rejection area. Then to answer this question, we draw the distribution. We specify the critical value based on the alpha level. The critical values that we calculated before is negative 1.96 and positive 1.96. And from our calculation, Z-stat is equal to negative 2.0. This negative 2.0 falls into the rejection area to the left, which is less than negative 1.96. So since the test value is less than negative 1.96 and falls into the rejection area, so our decision is to reject the null hypothesis. So step number 6, reach a decision and interpret the result. Since negative 2.0 is less than negative 1.96, we reject the null hypothesis and conclude that there is sufficient evidence that the mean diameter of the manufactured bulb is not equal to 30. So when we reject null hypothesis, we are going to write as the conclusion will be sufficient evidence to reject. If we fail to reject the null hypothesis, then we will write a conclusion there is not enough evidence to reject. So that is how we use the word sufficient evidence, not sufficient evidence. So again, when we reject null hypothesis, the conclusion will be there is enough evidence to reject. If we fail to reject, then we conclude there is not enough evidence to reject. So here, since we reject the null hypothesis, we conclude that there is sufficient evidence that the mean diameter of a manufactured bulb is not equal to 30. Okay, now let's take a look at the p-value approach for testing hypothesis. P-value represent the probability of obtaining a test statistic equal to or more extreme than the observed sample value given null hypothesis is true. The p-value is also called the observed level of significance. It is the smallest value of alpha for which null hypothesis can be rejected. Interpreting the p-value. So when we use the p-value, we have to compare with alpha level, alpha value. So if the p-value is less than alpha value, the decision is to reject null. If the p-value is greater than alpha value, do not reject null. So that is the rule that we have to follow. So just remember, that's a simple way to remember this. If the p-value is low, then null must go. P-value is low, then null must go. We can further simplify it as P low, Ho go. P low, Ho go means if the p-value is less than alpha, reject null. So remember, the shortest way or the easiest way to memorize the rule, the p-value rule, is to remember this word P low, Ho go. When P is lower than alpha, null must go. Null must be rejected. So there are 5 steps p-value approach to hypothesis testing. First step is to state the null hypothesis H0 and the alternative hypothesis H1. Step number 2, choose the level of significance alpha and the sample size n. Step number 3, determine the appropriate test statistics and the sampling distribution. Step number 4, collect the sample data, compute the value of the test statistic and the p-value. Step number 5, make the statistical decision and conclusion. Here is an example of how to use p-value in hypothesis testing. Again, this is the statement, the hypothesis statement. Test the claim that the true mean diameter of a manufactured bulb is 30 mm. Assume standard deviation of the population equal to 0.8. So this is the step we have to follow. State and the appropriate null and alternative hypothesis. So we write the null and alternative hypothesis as H0 mu equal to 30, H1 mu not equal to 30. And again, this is a two-tailed test. Step number 2, we specify the desired level of significance and the sample size, which is alpha equal to 0.05 and n equal to 100. Step number 3, determine the appropriate technique. In this case, we are going to use z-test because standard deviation of the population assume none. Step number 4, collect the data, compute the test statistics and the p-value. Suppose the sample results are n equal to 100, mean sample equal to 29.84, standard deviation is equal to 0.8 is assumed none. So the test statistics is gain negative 2.0. So z-stat equal to negative 2.0. So number 4, calculate the p-value. So how to calculate the p-value? So here we have the z-stat negative 2.0 to the left and to the right 2.0. So then we have to, based on this value, z value, we have to find an area to the left and to the right. So by looking at the z distribution, when z equal to 2.0, give you an area 0.0228 to the right and 0.0228 to the left. That is actually represent the p-value. So p-value is derived from the z-stat or z-statistic. So now since we have two rejection area or two p-value to the left and to the right, we have to combine the two values. So we add the two values. So p-values now become 0.0456. So then step number 5 is the p-value less than alpha. P-value is 0.0456, which is less than alpha value, which is 0.05. Remember the rule, when p is lower than alpha, reject null hypothesis. So in this case, we reject the null hypothesis, and the managerial conclusion for this situation is that when we reject the null hypothesis, we write there is a sufficient evidence to conclude the mean diameter of the manufactured hole is not equal to 30 millimeter. The third approach for hypothesis testing is to use confidence interval. For confidence interval is suitable for two-tailed test situation. So here again, this is the formula for confidence intervals. This formula comes from chapter 8. X bar plus or minus z alpha divided by 2. Alpha divided by 2 indicates this is a two-tailed test. And times the standard error. Standard error is standard deviation divided by square root n. So for our case, we have sample mean equal to 29.84, standard deviation of the population equal to 0.8, and sample size equal to 100. And we are going to build 95% confidence intervals because our alpha is 0.05, that is 5%. So based on using this formula, x bar plus or minus z alpha divided by 2, standard deviation population divided by square root of n. So we plug in all the values into the formula. So we got this value, confidence interval value. Mu is greater than or equal to 29.6832. but less than 29, less than or equal to 29.9968. So that is our confidence interval. So by using this information, we can make a decision whether to accept or to reject the null hypothesis. So remember, our null hypothesis is stated as mu equal to 30 and alternate hypothesis mu not equal to 30. So since this interval does not contain the hypothesized mean, that is 30 here, the null hypothesis stated as mu equal to 30. Since the interval does not contain 30, so we have to reject the null hypothesis at alpha equal to 0.05. So 30 is outside this range. So then we have to reject the null hypothesis. Do you ever truly know standard deviation of the population? That is the big question. Probably not. In virtually all real world business situation, sigma is unknown. Sigma is not known. If there is a situation where sigma is known, then for sure the mean of the population or the mu is also known, because we have, so since to calculate standard deviation you need to know the mean. If you truly know mu or the mean of the population, then there will be no need to gather a sample to estimate it. So here we have a situation, the real situation, where hypothesizing for the mean where population standard deviation is unknown. So if the population standard deviation is unknown, you instead use the sample standard deviation. So since we do not know the value of the population standard deviation, we can estimate it using the sample standard deviation S. So because of this change, you use the t distribution instead of the z distribution to test the null hypothesis about the mean. When using the t distribution, you must assume the population you are sampling from follows a normal distribution. So make sure your t distribution, or you have to assume your t distribution follow the normal distribution. All other steps, concept and conclusion are the same as z distribution. So here is the formula that we have to use in the situation where population standard deviation is unknown, and this formula is for the t-test. So here we have to use x bar minus mu divided by sample standard deviation divided by square root of n. So instead of using standard deviation of the population in the z-stat situation, we have to change to S or sample standard deviation in the case of t-stat. Okay, this is an example for population standard deviation unknown. The mean cost of a hotel room in Penang is said to be Rm 168 per night. To determine if this is true, a random sample of 25 hotels is taken and resulted in an x bar of Rm 172.50 cents and standard deviation of the sample of Rm 15.4. Test the appropriate hypothesis at alpha equal to 0.05. So this is example for two-tailed test where standard deviation of the population is unknown. So we also have to assume the population distribution is normal. So here we have to write our, or to state our hypothesis null and alternative. Mu is equal to 168 for the null hypothesis. For the alternate hypothesis, stated as mu not equal to 168 Rm per night. So since we are going to use the t-test in the case where standard deviation of population is unknown and the alpha level is set at 0.05 and n is equal to 25 sample size, degrees of freedom, we have to find the degrees of freedom for the t distribution. The formula is n minus 1. So since the n is 25 minus 1, so degrees of freedom equal to 24. So to find the critical value, you have to look into the t distribution based on the degrees of freedom 25 and alpha level equal to 0.05 for the two-tail test. So for the two-tail test, 24 represent the degrees of freedom, and this is the alpha level divided by 2. 0.05 divided by 2 is equal to 0.025, and based on these two information, we use your t-table to find the value for this critical value of t. So we got 2 point plus or minus 2.0639. This is from the t-table at degrees of freedom 24 and alpha 0.025. Then we draw the distributions for the two-tail test where this is the critical value t equal to negative 2.0639 to the left, and to the right we have a critical value equal to 2.0639, and we use the calculated value, the t calculated or the t stat value, which is 1.46. 1.46 come from this formula, the t stat formula, x bar minus mu divided by sample standard deviation divided by square root of n. So x bar is equal to 172.5 minus the mu, the population mean 168, divided by 15.40, that is the standard deviation, divided by square root of 25, the sample size, and we have a value equal to 1.46. And then value of 1.46 stated as the t-stat or the t calculated. Then we look at the location of this 146 in this distribution. So it falls in the non-rejection area. So 146 is less than the critical value 2.0639. So it is now in the non-rejection area. So do not reject null hypothesis because t statistics is less than the critical value. So our conclusion is that there is insufficient evidence that the true mean cost is different from RM 168. That is the conclusion of our test conclusion. Since we do not reject, we fail to reject the null hypothesis. So to use the t-test, we must assume population is normal. As long as the sample size is not very small and the population is not very skewed, the t-test can be used. So t-test actually is also known as the robust design. Robust design means it can accept many changes. To evaluate the normality assumption, you can determine how closely sample statistics match the normal distribution theoretical properties. Construct a histogram. So you can construct a histogram and stem and limb display box plot or normal probability plot as more detailed evaluation normality. So connection of the two-tailed test to confidence intervals. So again, we can use confidence intervals to help us to make decision whether to accept or to reject null hypothesis. In our example, we have a sample mean equal to 175.5, sample standard deviation equal to 15.40, and n equal to sample size equal to 25, and we want to construct 95% confidence interval for the population mean. So here we use the formula found in chapter 8 again. So this is the x bar minus the t that the t that comes from the tables, and times 15.4 is the sample standard deviation divided by square root of n is 25 sample size, positive and negative, plus and minus and plus. So we got as a result 166.14 to the left and 178.86 to the right. So here we have mu population mean equal to or greater than 166.14 but less than or equal to 178.86. So since the interval contains the hypothesized mean, we hypothesize the population mean equal to 168. So 168 is within this range. We have 168 within this range. So our conclusion is that our decision is not to reject the null hypothesis. We fail to reject the null hypothesis, and there is not enough evidence to do that at alpha level equal to 0.05. So this is our null hypothesis. This is our alternate hypothesis, 168. So 168 is within this range. We have to accept the null hypothesis. So that is the end of part 2 of chapter 9. Thank you very much.